basically, we're taking the square root of both sides to get the answer. That also works when we have perfect square trinomials, or in this case, we're going to end up with a perfect square. So if I just have x squared and no, so only an x squared, no x, then you want to make it x squared equals the number. And then take the square root of each side. Okay, so in this first example, I'm going to add 25 to both sides, which will give me x squared equals 25. And then I'll take that square root of each side, and I'll go x is equal to plus or minus 5. And it has to be both, plus and minus, because 5 squared is 25 and negative 5 squared is also 25. So you want both. The positive is considered to be like the primary answer, but both answers are valid. If you have a trinomial, and it's a perfect square trinomial, first you factor it. So to check if this is a perfect square trinomial, I take the square root of each of these. So the square root of x squared is x, the square root of 9 is 3, and if I multiply those by 2, I get 6x, which matches. So it is a perfect square trinomial. So the factored form of that is going to be x plus 3 squared. After I factor it, I take the square root of each side. Well, the square root of x plus 3 squared is x plus 3. And the square root of 0 is 0. And then I solve by subtracting 3 from both sides. And x is negative 3.
Can you do the factoring part again?
Yeah. To check to see if it's a perfect square trinomial, what we do is we take like the square root of this term and the square root of this term. Square root of 9 is 3. Square root of x squared is x. And then you multiply all that together times 2. So 2 times x times 3 is 6x. And it should match this middle term. If it matches, it's perfect square trinomial. If it doesn't match, it's not, and you have to factor it another way. But it's always, this times 2 is just kind of one of those things you just have to remember to multiply by 2. It's always going to be a 2. And then the square roots of the first and last. And this is just to check for perfect square trinomial. Yeah. If it doesn't match the middle term, then it's not a perfect square trinomial, and you'll either have to factor it a different way or use another method for solving. So I'm going to take the square root of the first and the square root of the last, and I get x and 6, and I'm going to multiply those together by 2. So 2 times x times 6 is 12x. And 12x does match, so it's perfect. Now the difference between here, I had positive, so this was plus. See that? Here it's negative, so if the middle term is negative, so is this. So it's x minus 6 squared equals 0. So just put a note out there. Okay. So I'm going to take the square root of both sides. and I'm going to get x minus 6 equals 0. Add 6 to both sides, and you get x equals 6. Now, I've told you that, I think I've told you, every time you have a quadratic, like an x squared, and 2 is your highest exponent, you're getting 2 answers. But when you have a perfect square trinomial, it looks like only one. This is called a repeated root. And this is what happens when we're graphing and it's just touching in one spot. So that's the only time you just get one answer, is if you have a perfect square trinomial. Every other time you'll get 2. And then, does anybody have questions about why this jumps to that? Like the square root of x minus 6 squared? But we get something called irrational roots. So when this happens, I have a perfect square trinomial here. I'm going to take the square root of each of these, multiply it by 2, and it equals 10x. So it matches. So I know that's a perfect square trinomial. So when I factor it, I'm going to get x minus 5 squared equals 27. And I'm going to take the square root of both sides. And that's not a perfect square. Yeah, so I'm going to do that factor tree. And I'll just do it over here. So I have 3 times 9, and 9 is a perfect square. So this is plus or minus 3 times the square root of 3. So this 3 that's left behind stays inside, and this pair of 3's is what comes out. Yeah, plus or minus 3. And it has to be plus or minus. This plus or minus is vital. Then I'm going to add 5 to both sides. Well, this side, easy, x. So what do we do over here? This plus 5 just hangs out in front. And it becomes 5 plus or minus 3 times the square root of 3, because I can't actually combine these, because this has a radical and this doesn't. And that's as far as you can go unless you want to convert into decimals. I'm going to check, is this a perfect square trinomial? 2 times 4 times x is 8x, so yes it is. So this is going to factor to x plus 4 squared is equal to 20. I'm going to take the square root of both sides. And 20 is not a perfect square, but it is 4 times 5, and 4 is a perfect square. So I get x plus 4 is equal to plus or minus 2 times the square root of 5. And this time I'm going to subtract 4 from both sides. And so I'll have a negative 4 hanging out front, plus or minus 2 times the square root of 5.
Where did you get the 2 roots?
From the 20, 20 is 4 times 5, and 4 is 2 times 2, so that perfect square 4 comes out as a 2. And then this 5, he gets left behind because he doesn't pair up with anyone. Yeah.
You didn't have a negative 4, just with the plus and minus.
Yeah, you'd always, anytime from now on, when we take a square root of any number, that's going to be plus or minus 5. Because we're getting into those quadratics, and so we need both. The positive 5 that we've been doing in the past is considered to be the primary root. The negative 5 is like a secondary root, but we need both now because we're dealing with quadratics. So if I were to do this, it's now going to be plus or minus 5i. So we're going to need both, the positive and the negative. Okay. as you can see from these examples, when you have these perfect square trinomials, they're kind of nice because they factor easily, and then you just take the square root, and it's all very, I mean, it's not long, so it's nice, right? As far as factoring goes. Well, completing the square is the act of forcing the equation to have a perfect square trinomial. So we're going to take the equation that we have, and we're going to force it to be a perfect square trinomial so that it looks all pretty and nice and it's easy to factor. This works best, if you remember, the standard formula of a quadratic is a squared plus b squared, or sorry, ax squared plus bx plus c, right? This works best if b is even. Now you can do it if b is odd, but when you do that, you're going to deal with fractions. And you're going to be squaring fractions and taking square roots of fractions, and you guys don't like fractions. So it works best if b is even. And I'm going to show you both cases. But when it comes time for the test, I'm going to give you some quadratic equations that need to be solved. And I'm going to say solve by any method. So you can use graphing, factoring, completing the square, quadratic formula, stuff like that. So here are the steps. We're going to take b and divide it by 2. Okay? And then we're going to take this answer, whatever that number is, and we're going to square it. And that will equal c. So to find our c to make this a perfect square trinomial, I'm going to take 16 and I'm going to divide it by 2. And that's 8. And then I'm going to take 8 and I'm going to square it, and that is 64. So to make this a perfect square trinomial, it will be 8 squared plus 16x plus 64. This is now what we want. I'm going to take this, I'll keep the negative in there just so you know what it's going to look like. That's negative 7. Negative 7 squared is 49. So my new perfect square trinomial is this. And just, if it were to factor, it'll be x minus 7 squared. To solve an equation by completing the square. So the whole point of completing the square is to make equations easier to solve. So the step 1 is you want to set it up to where you have x squared plus bx equals whatever number that is. Okay. Then the second step is to take b and divide it by 2, then square it. And then the third step is to add that to both sides. The fourth step is to factor the trinomial, because we made it a perfect square, so it's easy to factor. take the square root of both sides. And then you solve. Okay, so that looks like a lot. It's not that bad when you actually do it. So I'll give you time to write down the steps. All right, so the first thing we want to do, excuse me, is set it equal to, so it's x squared plus bx equals some number. So to do that, I'm going to add 11 to both sides to get the x's alone. So I'm going to have x squared plus 10x equals 11. Okay. Then I'm going to divide b by 2 and square it, just like we were doing before. And now I'm going to add this 25 to both sides. And the reason I have to add it to both sides is because if I only add 25 to one side, it's no longer the same value. You have to, whatever you do to one side, you do to both, right? So then I'm going to factor it. This will be factored to x plus 5 squared, and that's 36. I will take the square root of both sides. So I get x plus 5 is equal to plus or minus 6. Subtract 5. And what I get is x is equal to negative 5 plus or minus 6. And since these are like terms, I can actually do this plus or minus. So it ends up being negative 5 plus 6 and negative 5 minus 6. You do both. You do the plus and the minus. So negative 5 plus 6 is 1. Negative 5 minus 6 is negative 11. So here are my two answers.
How come you couldn't do it at 5?
I'm going to subtract 23 from both sides. And I'm going to get x squared minus 8x is equal to negative 23. I'm going to take negative 8 and divide it by 2, which gives me negative 4. I'm going to take that negative 4 and I'm going to square it, which is going to give me positive 16.
Does that say plus 8?
Here? Negative. No, it's a minus. Sorry. So then I'm going to add 16 to both sides. Factor. So that's x minus 4 squared. And then negative 7. Yeah, negative 7. I'm going to take the square root of each side. And I get x minus 4 is equal to plus or minus the square root of negative 7. Well, 7 doesn't have a square root in it, but that negative has to come out. So this is actually x minus 4 is equal to plus or minus I square root of 7. So imaginary, because the square root of a negative is imaginary. They made it up. Add 4 to both sides, and you get x is equal to 4 plus or minus I times the square root of 7, and I cannot do anything with any of that, so I'm done. That's my final answer. First thing you have to do in a situation like this is you have to divide everything by that leading coefficient. Because you're not allowed to have a number here when you're completing the square. So I have to divide everything by 2. And so I get x squared minus 3.5x plus 2.5 equals 0. Then I complete the steps to complete the square. So I'm going to set this equal to negative 2.5. I'm going to take this negative 3.5 and then I'm going to divide it by 2. So I'm going to get negative 1.75, I believe. Let me just double check myself. Yeah, 1.75. And then I'm going to take that negative 1.75 and I'm going to square it. And I'm going to get 3.06. I'm going to leave off the 2.5 because that's just a lot. And I'm going to add that to both sides. Here? I subtracted, yeah. Sorry. Okay, so this will factor to x minus 1.75 squared, and then 3.06 minus 2.5 is 0.56. And I'm going to take the square root of both sides. And I'm going to get x minus 1.75 is equal to plus or minus. If you have a decimal, you have to do the square root. So it's 0.75. So I'm going to add 1.75 to both sides. And I'm going to get, x is equal to 1.75 plus or minus 0.75. So, yeah. Uh-huh. X squared minus 3.5x plus 3.06. Negative 2.5 plus 3.06. So I have to do the 1.75 plus 0.75 and 1.75 minus 0.75. So $2.51. So stick with decimals, or would you guys like to see fractions? Alrighty. We're going to have to do some rounding on this because that's going to be 3.3 repeating. And then I think that's going to be 2.3, oh, 2.6. So 2.7. Okay. I'm going to add that 2.7 to both sides. Actually, I can write a little bigger than that. So I'm going to add that 2.7 to both sides. So I'm going to x squared plus 3.3x equals 2.7. I'm going to take 3.3 and I'm going to divide it by 2. The 3 is repeating, but we're rounding because we can't really work with a repeating decimal. So it's 1.65. And then 1.65 squared, no clue. 2.72. So I'm going to add that 2.72 to both sides. So I'm going to get x plus 1.65 is equal to 5.42. I'm going to take the square root of each. Oh, sorry, that should be a squared right there. Left it off. And then I'm going to come up here so I have more room. And I'm going to get x plus 1.65 is equal to 2.33 plus or minus. Sorry, let me fix that. And then I'm going to subtract 1.65 from both sides. And so I get that x is equal to negative 1.65 plus or minus 2.33. So I have negative 1.65 plus 2.33 and negative 1.65 minus 2.33. So 2.33 minus 1.65. So 0.68. Negative, what was that, 3.98. Imaginary solutions. We actually ended up with one of those because I think I made a typo, but that's all right. We'll just pretend we hadn't seen one yet, and we'll go ahead and complete the square. And we like this one because it's all pretty and even is good. So I'm going to take 8, and I'm going to divide it by 2, and I'm going to get 4, and I'm going to square that 4 to get 16, which I'm going to add to both sides. And this is going to give me x plus 4 squared is equal to negative 6. I'll take that square root of both sides. And I get x plus 4 is equal to plus or minus the square root of negative 6, but I can't have a negative. So I have to bring it out. So x equals 4, no, sorry. X plus 4 equals plus or minus I times the square root of 6. And if I subtract 4 from both sides, I get x equals negative 4 plus or minus I root 6. All right, so we're going to take that 25 and subtract it from both sides. X squared minus 6x equals negative 25. I'm going to take that negative 6 and I'm going to divide it by 2, and it's going to give me negative 3, which I'm going to square to get 9. And I'm going to add that to both sides. And this will factor. Sorry, that's not a plus, that's a minus. So x minus 3 squared is equal to negative 16. I'm going to take the square root of both sides. I'm going to get x minus 3 is equal to plus or minus. Okay, the square root of 16 is 4, and the negative gives me I. So plus or minus 4I. I'm going to add 3 to both sides. And I'm going to get x is equal to 3 plus or minus 4I. And again, part of it's real, part of it's imaginary, so it stays just like that. We had graphing, which works, we had graphing, which gives us perfect answers sometimes when you have perfect integer roots. We have factoring, which works sometimes because some things aren't factorable. We have completing the square, which will work every time, but sometimes it's not so pretty. Quadratic formula works 100% of the time. And this is the quadratic formula. And what you have is you want to put the quadratic equation into standard form, which is ax squared plus bx plus c equals 0. So this is the first step. You must have it in standard form for this to work. So you set it equal to 0, and then this a, whatever number that is, gets plugged in 2 places. This b gets plugged into 2 places. And this c gets plugged in once. And so you plug in these numbers, and then you do some multiplying, some subtracting, square rooting, maybe adding and subtracting and dividing. Maybe. You can't always do that part. And like I said, the beauty of it is it works 100% of the time. Of course, in order for it to work, you have to know it. There are 2 more fun ways to learn this thing. One is annoying, but like all annoying things, especially songs that are annoying, it'll get stuck in your head. Like how many of you know the words to Call Me Maybe and really wish you didn't, right? Okay, because it's stuck in your head because it's annoying. It's just, right? So, you know the song Pop Goes the Weasel? If you sing the quadratic formula, it fits perfectly to Pop Goes the Weasel. So now I'm going to sing. You're not allowed to laugh. Ready? X equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. Pop Goes the Weasel, right? Perfect. So you can sing it in your head, and you'll memorize it that way.
Yeah.
Or you can learn this cool story. We have a negative boy who couldn't decide whether or not to go to the radical party, but he was square. Oops, I wanted to change colors. And so he missed out on 4 awesome chicks. And it was all over by 2 a.m. So the words tell you what to write. And I don't care how you memorize it, but you do need to memorize it because you're going to need it. Okay, the first step is we have to set it equal to 0. So if there's a number on the other side of the equal, we need to subtract or add it to both sides so that the whole thing is basically on one side of the equation. Okay. Number 2, we need to identify A, B, and C. So if there's no number there, A is 1, B is negative 10, and C is negative 11. Don't forget those negative signs if they're there, okay? Next, we plug into the formula. All right, so I'm going to write down the formula again. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, negative b. Well, b was negative 10, so I have a negative negative. Okay, so we have negative negative 10 plus or minus the square root of negative 10 squared, because that was b again, minus 4 times a, which is 1, times c, which is negative 11. All over 2 times a. Right? Now we're going to do what I like to call, so we plug and then we chug. So we plug in the numbers and then we chug out the math. So first of all, I'm going to deal with this negative negative 10. That's positive 10. 10 squared is 100. Negative 4 times negative 11 is positive 44. 2 times 1 is 2. Any questions from there to there? Okay. So then I have 10 plus or minus the square root of 144 over 2. Square root of 144 is 12. So 10 plus or minus 12 over 2. And then what I need to do is I need to do 10 plus 12 divided by 2 and 10 minus 12 divided by 2. So 10 plus 12 is 22. Divide that by 2, I get 11. 10 minus 12 is negative 2. Divide that by 2, I get negative 1. So I have 2 rational roots here. Everything worked out nicely and evenly, and I got whole numbers. So I don't have to do that part. I have A, B, and C. So a negative boy couldn't decide whether or not to go to the radical party, but he was square, so he missed out on 4 awesome chicks. And it was all over by 2 a.m. So I'm going to plug those in. B is 25, so I have negative 25 plus or minus the square root of 25 squared minus 4. A is 2, C is 33 over 2 times A, which is 2. So that's negative 25 plus or minus the square root of 625 minus, so I need to do 4 times 2 times 33, 264, over 4. So I have negative 25 plus or minus the square root of 361 over 4. I think that's 19. Yes, it is. So I have negative 25 plus or minus 19 over 4. So it's negative 25 plus 19 divided by 4, and negative 25 minus 19 divided by 4. Okay, so that's negative 6 over 4, and 25 and 19 is negative 44 over 4. Okay, now this 6/4, you can either reduce it and leave it a fraction, or you can make it into a decimal. I'm just going to leave it as a fraction. And here are my 2 answers. We get something else happening under the radical. So A is 1, B is 8, C is 16. So if I plug these in, I get -8 plus or minus the square root of 8 squared minus 4 times 1 times 16 over 2 times 1. So I get -8 plus or minus the square root of 64 minus 64 over 2. Well, 64 minus 64 is 0. So I get -8 plus or minus 0. Well, that's just silly. That's just -8. So I get one answer. So if you have a 0 under the radical, this gives you one answer. I'm going to back for just 1 second. If this is a perfect square, I get 2 rational, which means no square root, answers. Okay? If it's a 0, I just get one answer. So we've had rational roots and 0. So now we're going to see what happens when you get a irrational root. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. It's going to get stuck in your head, you'll see. So I have -b, which is 6, and then b squared, which is 6 squared, minus 4 times a times c over 2 times a. So it gives me -6 plus or minus 36 plus 28 times 2, so 56 over 4. -6 plus or minus 92 over 4. So I have to figure out what is the square root of 92. It's not a perfect square. 92 is 2 times 46, which is 2 times 23. So I've got that set of 2's that can come out. So I have -6 plus or minus 2 times the square root of 23 over 4. Once this happens, your answer is going to look like this format, but I need to compare these three. What was that? I need to compare these 3 numbers to see if they'll reduce. Basically, I had to see, will all 3 of these divide by the same thing? If all 3 don't, you're done. But in this case, all 3 will divide by 2. So I'm going to divide each of them by 2. So I have -3 plus or minus the square root of 23 over 2. And then I'm done. And you just leave it just like that. You don't have to do anything with this. You don't have to find out what the square root of 23 is. You're done. Now, if you want to, you can get the decimal answers and add and subtract and divide by 4 and go from there. Or you can just leave it like this. So I have to set this equal to 0. So it's going to be plus 10 equals 0. Write down my quadratic formula, plug in my values. So I have -6 plus or minus -6 squared minus 4 times 1 times 10 over 2 times 1. So I'm going to get 6 plus or minus the square root of 36 minus 40 over 2. So that's 6 plus or minus the square root of -4 over 2. So we have that -4. So we have to bring out that I and then 4. So it's 2I divided by 2. And 6 and 2 will both divide by 2. So this is going to give me 3 plus or minus I. So if you have a negative, you get 2 imaginary roots. And what this means is this parabola, if we drew it, it doesn't touch the x-axis. That's when you get imaginary roots, is when you don't actually touch the x-axis. So the discriminant is just b squared minus 4ac. It's the part under the radical. Now, if it's greater than 0 and it's a perfect square, you get 2 rational roots. So whole numbers, fractions. If you have this positive and it's not a perfect square, you get 2 irrational roots. Okay, so what's going to happen is you're going to have a graph where the parabola is crossing the x-axis twice. So when this happens, you can graph if you want to. When you have the discriminant equal to 0, you get 1 repeated root. And it's rational. And that is what happens when your parabola is touching the graph in just one spot. So again, these 3 you can solve by graphing. But if it's less than 0, so that's negative, right? You're getting 2 imaginary roots. So if you tried to graph it, it doesn't touch the x-axis at all. These cannot be solved by graphing. So if any of you prefer graphing as your method for solving, you need to check and see if this is positive or negative. Because if it's negative, you're not going to be allowed to use graphing because you can't, there's no way to get there from graphing. So if this is negative, you'd have to use one of the other options. Okay? What to do to figure that out is you take b squared minus 4ac. So I go, okay, 11 squared. I'll write that down. 11 squared minus 4 times 7 times 5. So it's 121 minus 140. So that's going to be negative. Bless you. So I'm going to have 2 imaginary roots. Bless you. Okay, because it was negative. So this one I would not be able to graph. I also couldn't factor it, because if it's imaginary, it won't factor. So for this particular problem, I would have to either use the quadratic formula or completing the square. Here, if I do b squared minus 4ac, I have 8 squared minus 4 times negative 5 times negative 1. So I get 64 minus 20, which is 44. So I'm going to have 2 irrational roots. Okay. Irrational roots cannot be factored. You can graph them, but you'll be estimating. So you could graph this, or you could use completing the square or quadratic formula. You just couldn't factor it. Do you get the idea? Okay. Sometimes. When you use it, when you don't need exact answers. Factoring can be used sometimes. When can you use it? When it will factor. They don't always factor. Square root property, sometimes. If you have a perfect square, completing the square can be always, but it's best if A is 1 and B is even. And quadratic formula is always, and when you can use it, anytime you want.